Right now, there are dozens of videos on YouTube telling you that a $30 antenna on your roof can pull free electricity out of the atmosphere. No solar panels, no generator, no utility bill, just a length of copper wire, a capacitor, and the open sky. Here is the part that makes this dangerous instead of just silly. None of it is completely made up. The atmosphere really does carry an electrical charge. Nikola Tesla really did spend years studying how to draw power from the environment around us, and he even patented a system to try it. So when someone shows you a meter reading, a wire running up to the sky, and Tesla's name attached to the idea, it doesn't sound like a scam. It sounds like a secret finally getting out, but there is one number missing from almost every one of those videos. It never gets mentioned on camera. And once you understand what it actually is, the entire unlimited power claim falls apart in about 10 seconds. That number isn't voltage, it's current. To understand why that distinction matters, we have to go back to a summer in 1899 to a remote laboratory outside Colorado Springs, where Tesla was running high-voltage experiments most of his contemporaries thought were impossible. He was transmitting electricity without wires. He was lighting bulbs from a distance no one could explain. And he had become convinced that the sky above every rooftop on Earth was, in some form, part of a much larger electrical system, one that human beings might eventually learn to tap. If you're a homeowner watching your power bill climb every summer, or thinking about backup power for the next time the grid goes down, that idea is genuinely appealing. A source of electricity that's already sitting above your house, costing nothing, waiting to be collected. It's the kind of story that makes you want to believe there's a shortcut the utility companies never told you about. So this video is going to answer 3 questions honestly, without turning Tesla into a cartoon and without turning atmospheric electricity into a fantasy. What was Tesla actually trying to collect? Did he really pull usable electricity out of the air, and if so, how much? And why doesn't that mean a $30 antenna on your roof can power anything in your house? Here's the first thing worth holding on to as we go. There is a specific number buried in this story that makes almost every unlimited atmospheric power claim collapse the moment you look at it directly. We'll get to exactly what that number is, and here's the second thing. Tesla wasn't wrong because he misunderstood electricity. Nobody in his era understood it better. He ran into a physical limit, one that more than a century later still hasn't been solved at the scale of a house. So if the voltage in the atmosphere is real, and Tesla really did build systems to try to harvest it, why can't a small antenna on your roof turn that into usable electricity today? Free energy videos love showing you a voltage reading. A number in the hundreds, sometimes the thousands, flashing on a multimeter screen. It looks impressive. It looks like proof, but your washing machine, your phone charger, your porch light, none of them run on voltage alone. They run on power, and power is voltage multiplied by current. Power equals voltage times current. P equals V times I. That equation is the whole story, and almost nobody selling you a roof antenna wants to talk about the second half of it. Here's the mistake most people make, and it's an easy one to make, because it's built on a pattern you already trust. In everyday life, high voltage usually means danger, and danger usually means power. A 220-volt outlet will hurt you far worse than a 1.5-volt battery. A high-tension power line sounds more serious than a phone charging cable. So your brain does the math automatically. High voltage equals a lot of electricity equals something you can use. That instinct isn't wrong about danger, it's wrong about usefulness, because voltage only tells you how hard the electricity is pushing. It says nothing about how much of it is actually flowing. Picture a water tank sitting at the top of a mountain, connected to your house by a pipe. If that tank sits high enough, the pressure at the bottom of the pipe can be enormous. But if the pipe itself is as thin as a human hair, none of that pressure matters. Water will trickle out, drop by drop. You could stand under it for an hour and never fill a cup, let alone run a shower or a washing machine. The pressure is real, the flow is not. That's exactly what happens with atmospheric electricity. The voltage between the ground and the air above your roof can genuinely reach into the hundreds or even thousands of volts under the right conditions. But the current, the actual flow of electrons, is often stuck somewhere in the nanoampere to microampere range. That's not a typo, that's millionths, sometimes billionths, of a single ampere. Now picture the homeowner this video is actually made for. He watches one of these Tesla antenna videos, orders some copper wire, a capacitor, a diode, and a grounding rod online. He wires it up, clips a multimeter to it, and sees a few hundred volts on the display. For a second, it feels like it worked. Free electricity, right there in his hands. Then he connects it to something real, an LED, a phone, a small fan, and nothing happens, or worse, something flickers for half a second and dies. The voltage reading was never lying to him. What it never told him was the current, and without current, voltage is just a number on a screen. Let's put an actual figure on it, because vague warnings don't stick, but numbers do. If a system produces 1,000 volts but only 1 microamp of current, the total power output is around 1 milliwatt. 1,000th of a single watt, a typical LED bulb draws somewhere around 8 to 10 watts. A phone charger draws several watts. You would need thousands of these atmospheric collectors, stacked and combined, just to approach the power needed to charge a phone at a normal speed, and that's before accounting for all the losses along the way. High voltage is impressive on a screen, high current is what actually does work, and high voltage paired with a tiny current is, for practical purposes, mostly a demonstration. Here's what makes this genuinely interesting instead of just disappointing. Tesla wasn't a beginner who confused these two things. He understood the difference between voltage and current better than almost anyone alive in his era. He built entire systems specifically designed around that distinction. So if he knew a small collector wouldn't produce usable power, why did he still believe the atmosphere could be harvested at all? The answer isn't buried in a patent filing or a technical paper. It's sitting on a physics classroom shelf in a piece of 19th century equipment most people have never heard of, a device that can pull real electricity out of nothing but falling water and still surprises people who see it work for the first time today. In 1867, the Scottish physicist William Thomson, better known by his title, Lord Kelvin, built a strange little machine on his workbench. No battery, no wall outlet, no moving generator, just a thin stream of water dripping through a pair of metal rings into two separate containers below. It's called the Kelvin water dropper, and it's still sitting in physics classrooms across the United States today, mostly ignored, mostly unlabeled, mostly forgotten by anyone who isn't teaching an introductory electricity unit. Here's what it does, and why it matters for everything we just talked about. As water drips through the metal rings, each falling droplet carries a tiny electrical charge away with it. One side of the system accumulates a positive charge. The other accumulates negative drop by drop. That charge builds, left running for a while. Two metal spheres connected to the device can build up enough voltage to throw a visible spark between them. A small, sharp crack of electricity generated from nothing but gravity and falling water. No battery, no plug, no solar cell, and yet a spark. If you only watch this for the first 10 seconds, it would look exactly like the kind of clip those roof antenna videos love to use as proof. No visible power source, and yet electricity is clearly happening in front of your eyes. But this is exactly the device we need, because it lets us test the claim honestly instead of arguing about it in the abstract. The Kelvin water dropper generates real voltage, sometimes several thousand volts. What it does not generate is real current. It charges slowly, discharges in a single quick spark, and then has to build back up all over again before it can do anything else. It is, in the most literal sense, a voltage machine with almost no power behind it. Which brings us to the actual question this video keeps circling back to. How many watts does it deliver under a real load? The answer is close to none. You could not run a bulb off it continuously. You could not charge a phone off it. What you get is a spark, real, measurable, genuinely caused by separated electric charge, and then silence, while it slowly recharges for the next one. This is precisely the trap that free energy content relies on, whether the creators realize it or not. A spark looks convincing, a voltage reading looks convincing. Both are real phenomena. Neither one answers the only question that actually determines whether something can power your house. How much usable energy is available, and for how long? Tesla understood this distinction about charge separation and voltage buildup better than nearly anyone working in his era. He had already built devices that behaved like scaled-up versions of exactly what Kelvin's water dropper demonstrated on a desk. But instead of stopping at a tabletop spark, he thought bigger. If falling water could separate charge on a small scale, what about the atmosphere itself? the entire column of air between the ground and the clouds, treated as one enormous, if extremely weak, capacitor. That question is what led him to file one of the strangest and most specific patents of his career. On November 5, 1901, the United States Patent Office granted Tesla patent number 685-957, apparatus for the utilization of radiant energy. Strip away the antique legal language, and what's described inside is surprisingly close to what today's viral videos are selling: an elevated metal plate, raised high into the air, connected through a capacitor down to a rod driven into the earth. Here's the physics behind it, explained the way it actually works rather than the way it gets sold. On a clear day, the atmosphere carries a natural electric field. The air isn't neutral. It holds a charge that shifts with altitude, and the difference between the ground and the air above it is measurable. Scientists describe this as the atmospheric potential gradient, and in fair weather, it runs at roughly 100 volts for every meter of height. Stand outside on a calm, clear afternoon, and there's a real physical voltage difference between the ground under your feet and the air above your head. Tesla's idea was to treat that gap as a giant, if extremely weak, capacitor. Picture a metal plate lifted up into the sky. That plate behaves like one electrical terminal. The ground, connected through a rod driven into the earth, behaves like the other. The air in between acts as the insulating layer, the same role plastic or ceramic plays inside a capacitor you'd find in an electronics kit. Charge slowly accumulates on the plate, a diode lets it flow one direction and stops it from bleeding straight back out. Given time, that trickle of charge builds into something a capacitor can store. That's the whole mechanism. It's elegant and it's not fake. It's also, in practice, brutally inefficient, because the number that matters here, the one worth writing down, is that 100 volts per meter figure. It sounds enormous. What it doesn't tell you, and what almost never gets mentioned in the videos built around this patent, is how little current actually moves through a small plate under those conditions. Depending on the size of the collector, the altitude, the humidity, and how well it's insulated, the current drawn from a modest rooftop-sized panel typically sits somewhere between nanoamps and microamps, the same tiny range we already saw with the Kelvin water dropper, just spread out over a larger, slower system instead of a quick spark. This is exactly where the free energy videos take a shortcut that Tesla himself never took. They go from "the atmosphere carries enormous voltage" straight to "so you could charge your devices from it," skipping the one calculation that actually determines whether that's true. Tesla wasn't short on voltage, he had plenty of that. What he never solved was current, a steady, usable flow of electricity large enough to do real work. Here's a comparison that makes the gap concrete. A single AA battery holds 1.5 volts. That's almost nothing compared to the hundreds of volts sitting in the air above a rooftop. But that AA battery can push a real steady current through a small circuit, enough to run a flashlight, a remote control, a clock. The atmosphere can hand you a voltage reading that looks far more dramatic. What it can't hand you at small scale is a current anywhere close to what that battery delivers on command. High voltage, tiny current versus low voltage, usable current. Written side by side, it's almost the opposite of what most people would guess walking into this topic. Tesla knew exactly what this meant for scaling the idea up. If you want more current out of a system like this, there are only a few levers available. Raise the collector higher, make it bigger, improve the insulation, and give the system a better way to store what it gathers before it leaks back out. Every one of those levers pushes the design further away from something you could quietly bolt to a roof over a weekend. Which is exactly why Tesla didn't build a small antenna. He built a tower. On a hill in Shoreham, Long Island, construction began on Wardenclyffe, a structure designed at a scale nothing like the plate described in his patent drawing. It was an attempt to take a principle that barely produced a usable trickle at desk scale and force enough size into it to matter. It's the same instinct any engineer has when a small version of an idea technically works but doesn't produce enough to be useful. You don't shrink the goal, you grow the system. But scaling an idea like this up from a laboratory sketch into something standing outdoors, exposed to real weather, real humidity, and real wear, is where a very different set of problems shows up. Problems that have nothing to do with whether the underlying physics is real, and everything to do with why almost no one in over a century has ever managed to turn this into a working home power source. So if the principle is real, If the atmosphere genuinely carries a charge, and Tesla's patent genuinely describes a working mechanism, why isn't there a legal, tested, insured Tesla roof antenna sitting on the shelf at your local hardware store with a clear wattage rating printed on the box? The honest answer doesn't require a conspiracy. It comes down to 3 specific points where this idea breaks down the moment it leaves a controlled lab and gets bolted onto a real house. The first failure point is humidity leakage. Charge doesn't just sit patiently on a metal plate waiting to be collected. It bleeds away constantly, and moisture is one of the fastest ways it escapes. Damp air, dust, morning dew, a light drizzle, even a thin film of condensation on an insulator, all of these create paths for the accumulated charge to drain straight back into the environment before it ever reaches your capacitor. This is exactly why Colorado Springs wasn't a random choice for Tesla's experiments. The dry air and high altitude gave him conditions that most American homeowners simply don't have. A collector that might produce a faint trickle on a dry, clear day in the Rockies can drop to almost nothing on a humid summer evening in Georgia or a foggy morning in Ohio. The second failure point is collector size. A bigger, higher plate can pull in more current, but the increase is painfully slow, not dramatic. A small strip of wire, a cheap antenna, or a modest metal disc simply doesn't have enough surface area exposed to the sky to gather a meaningful current, no matter how high the voltage reading looks on a meter. Renaming a $30 length of copper wire a Tesla antenna doesn't change the physics underneath it. You cannot turn a microamp trickle into household electricity just by giving it a more impressive name. The third failure point is storage loss. Even in the best-case scenario, where a system manages to collect some charge, the charge still has to be stored without leaking away. Real capacitors aren't perfect, real insulation isn't perfect, real wiring, real weatherproofing, real outdoor conditions all introduce small, constant losses. If the rate at which a system loses charge is anywhere close to the rate at which it collects it, the net energy you actually get to use approaches zero, even though the meter might still show a voltage reading that looks encouraging. Here's a question worth sitting with for a second. If this technology genuinely delivered stable, usable electricity for next to nothing, why isn't it standard equipment at remote weather stations, isolated telecom towers, or off-grid military outposts, places where reliable power matters enormously and cost is rarely the deciding factor? The answer is that real engineering doesn't just ask whether a principle is real. It asks whether a system can deliver power that's stable, measurable, repeatable, weatherproof, insurable, and capable of running an actual load day after day in real conditions. A small atmospheric collector, even Tesla's own version, never cleared that bar. Not because the physics was wrong, but because the physics at that scale simply doesn't produce enough. So does that mean the whole idea is a scam start to finish? Not exactly. There's a real defensible core buried inside this story. It's just not the version being sold to you in a video promising unlimited power from a $30 wire. That distinction between a genuine physical principle and an exaggerated promise built on top of it is the difference this entire video has been building toward. At this point, it would be easy to slide into the next section of this video the way most of these channels do. A parts list, a wiring diagram, step-by-step instructions for mounting a plate on your roof and running a wire down to a grounding rod. That's not what's coming next, and here's why. Anything raised into open air on your roof, connected through a wire to the ground below, sits in the same general category as a lightning rod, whether it's marketed that way or not. Atmospheric voltage doesn't distinguish between a curious homeowner's weekend project and a legitimate hazard. This channel isn't going to hand you a set of instructions for building something that carries real risk in exchange for a result that, as we just walked through, produces essentially no usable power anyway. That trade doesn't make sense, and no viral video is worth it. If you want to actually see this principle in action, safely, the tool for that already exists, and it's sitting in physics classrooms across the country. A Kelvin water dropper, or any of the classroom electric field demonstration kits built around the same idea, will show you real charge separation and a real spark, using nothing but falling water or a hand crank generator. These devices are designed, insulated, and built specifically to demonstrate the principle without turning into a hazard. They're worth looking into if this topic genuinely interests you. But here's the distinction that matters. And it's worth saying plainly. A safe demonstration proves the principle is real. It does not prove the principle can power anything in your home. Set your expectations accordingly if you ever see one of these devices in person. You might see a small spark, you might see a needle move on a sensitive meter. That's a genuinely interesting piece of physics happening in front of you. What you should not expect from any tabletop version of this is a charged phone, a running fan, a lower power bill, a solar replacement, or a backup generator. None of that is what these devices were ever built to do. This isn't about dismissing the idea or making Tesla look foolish, and it isn't about mocking anyone who found the roof antenna videos convincing. It's about drawing a clear line between what's real and what's been stretched past what the physics actually supports. Once you can see that line clearly, you have a simple filter you can apply to almost any free energy video you come across from here on out. So here's where all of this actually lands. The atmosphere really does carry electricity. Tesla really did research high-voltage systems and long-distance energy transmission, and his patent for an elevated collector isn't a myth someone invented later. It's a real, granted document you can look up tonight. A raised plate, a capacitor, and a grounding rod really can produce a measurable difference in electric potential. None of that means a $30 antenna on your roof can generate unlimited electricity for your house. It can't. Nothing in this story ever supported that claim, not Tesla's original patent, not the physics of the atmospheric potential gradient, and not a single verified, independently tested rooftop build in over a century of people trying. 3 things are worth carrying with you the next time you come across a video like this. First, stop asking how many volts a free energy device produces. Ask how many amps. Voltage tells you how hard something is pushing. Current tells you whether there's anything behind that push worth using. Almost every misleading energy video in existence survives entirely on people never asking that second question. Second, don't trust a meter reading with no load attached. A voltage number on an unloaded circuit tells you almost nothing about real-world performance. Ask what happens when that device is connected to an actual bulb, an actual fan, an actual phone, and for how long it can keep that load running. That's the number that separates a working power source from a demonstration. Third, a forgotten technology isn't automatically a suppressed one. Sometimes the real reason something never made it to market has nothing to do with secrecy, and everything to do with the boring, unglamorous requirements of turning an idea into a product consistent output. Weather resistance, safety certification, insurance, manufacturing cost, and the ability to perform the same way on day 1000 as it did on day 1. Plenty of real physical principles never clear that bar, and that's not a cover-up. That's just engineering. It's worth saying something about Tesla directly, because he keeps getting used as a mascot for claims he never actually made. Tesla doesn't need to be turned into the face of a $30 miracle gadget to be worth admiring. What made him remarkable wasn't a secret shortcut around the power grid. It was his willingness to push right up against the edge of what the physics of his time could actually deliver. And that patent, sitting quietly in the historical record, is exactly where he found that edge. He didn't fail because he misunderstood electricity. He ran into a wall that, over 100 years later, we still haven't fully solved at the scale of a single house. If topics like this interest you, separating the real principle from the version being sold to you, this channel is built around exactly that. Testing old, forgotten home energy ideas, explaining the physics honestly, and being straight with you about what actually works and what doesn't. If that's useful, sticking around for the next one is the simplest way to keep seeing it. Speaking of which, the next video in this series moves away from electricity entirely and into something with a much better track record for actually cutting a power bill. An old, largely forgotten cooling principle that lets a surface radiate heat straight into the night sky, no electricity involved at all. That one's coming up next. The sky above your roof really is electrically charged. That was never the lie. The lie is when someone tells you that $30, a length of copper wire, and a small antenna are enough to turn that charge into the power source for your home.